Good morning. Today we shall continue with our discussion, but today we are mostly dealing with calculations. But before that, I would like to clarify something with regard to significant figures. For uh, for for numbers that end with zeros, the rules on significant figures complicate because, for example, for rule number 4, if there is a decimal point and the zeros lie either after or before it, they are significant. And the appropriate example for it would be 1.1300. So the zeros, the zeros here are significant since they are located after the decimal. And when we say that the zero is before the decimal point, we pertain to numbers such as 6. So the zeros lie before the decimal point. The rule is different from rule 3. Leading zeros are not significant since these zeros only place the non-zero digits of the whole number. And for rule number 5, if there is no decimal point, we assume that the zeros are not significant. So for this number, the zeros here are not significant. Therefore, the significant figures for 5,300 liters is 2. Unless we clarify it, since we said here, we assume. When we say assume, we pertain to the scientific notation. It clarifies things. For example, when we translate it to scientific notation, we have 5.3 times 10 to the third milliliters. So this time, we have 4 significant figures. So it clarifies things, ang scientific notation. Then we have lastly, terminal decimal point indicates that zeros are significant. So it's like rule number 4, but it's much clearer. So zeros before the decimal point are significant. Therefore, for 500 ml, there are 3 significant figures. So for today, we will be talking mostly about calculations. We have the calculations for moles to mass and mass to mole, mass percent, empirical and molecular formula, balancing chemical equations, stoichiometry, the calculations of percent yield, concentration, and lastly, titration. So first off, mole is the SI unit for the amount of substance. It is defined as the number of entities that has equal number of atoms in 12 grams of carbon 12. Carbon 12 here is an isotope. So an isotope would mean a difference. An isotope would mean same atomic number, but they differ in the mass number. So for molar mass, it is the mass of a mole of its entities. Entities may pertain to atoms, molecules, and formula units, and has units of grams per mole. Next, we have the Avogadro's number. The number its use is to determine how many molecules, atoms are there in one mole of a substance. Then we have atomic mass units. It is the mass of an atom in atomic mass units. So 1 AMU is equal to the mass exactly equal to 1/12 of the mass of one carbon-12 atom. So basically, we are just defining the terms that we will be using for our calculations. Then you might wonder, how did we come up with the atomic weights of our elements? So they are determined by calculating the average mass of naturally occurring mixtures of isotopes. So for example, for hydrogen, its mass is 1.01 grams per mole, but it is the average mass of H1, H2, 3H. So these are isotopes of hydrogen. So for our first problem, we are asked to calculate the molar mass of nitroglycerine, or its common name, dynamite. So first, we use the subscripts to calculate the molar mass of compounds. Then from the periodic table, we get the individual atomic weights of each element in the chemical formula. For carbon, we have 11.01 grams per mole, hydrogen 1.01, nitrogen 14.01, and oxygen 16.0. Its units are in grams per mole. So we multiply them by the subscripts. So since nitroglycerine has 3 carbon atoms, we multiply it by 3. And the other follows. So by calculating, we have 36.0 grams per mole, 5.05, 42.03, then 144. So the molar mass of nitroglycerine would be the sum of all multiplied weights. So this would be equal to 227.11 grams per mole. Yeah. Then we have Another problem which goes like this. 5 grams of salicylic acid is required for combustion with oxygen. Calculate the molar mass of salicylic acid, the amount of salicylic acid in moles, the number of molecules in 5 grams of salicylic acid. So we determine first the molar mass of salicylic acid. We have carbon, hydrogen, and oxygen. So we multiply them, 7, 6, and 3. So we get 54.07, 6.06, and 48. We add them together, we get 138.13 grams per mole of salicylic acid. Next, this is just the conversion between moles to mass. So when we have 5 grams of salicylic acid, we make use of the molar mass of salicylic acid. Earlier, we calculated 138.13 grams salicylic acid per 1 mole of salicylic acid. So these two units cancel out. Then we get 0.036 moles of salicylic acid. So if we were to convert moles to grams, we also make use of the molar mass but in such a way that we would be canceling out moles of salicylic acid. So basically, we use the molar mass as a conversion unit between moles to grams and grams to moles. Then lastly, we are asked to calculate the molecules of 5 grams of salicylic acid. So earlier, we had 0.038 moles. We make use of that. We multiply it to the Avogadro's number since it determines the number of molecules in a substance. Then per 1 mole of salicylic acid. So we cancel these terms out. Then we would get 2.18 times 10 to the 22 molecules of salicylic acid. So the units, by the way, of Avogadro's number is this. Entities per mole of a substance. So entities, again, they may be molecules, atoms, or formula units. So this example, it combines the previous problem into one. So we start off, we are given with 8.92 grams of nitrogen dioxide. Nitrogen dioxide is, so first, we calculate the molar mass of nitrogen dioxide, which is equal to 14.01 grams per mole plus 16.016 times 2, then we would get 46.01 grams per mole. So we have that. Then we make use of that to convert grams to moles. Then moles to molecules. So 8.92 grams nitrogen dioxide times this quantity per 1 mole of nitrogen dioxide. Then we make use again of the Avogadro's number, molecules of nitrogen dioxide per 1 mole of nitrogen dioxide. So calculating, we cancel these terms, these units. Then we are left behind with molecules of nitrogen dioxide. Then calculating, we would get this answer. So in 8.92 grams of nitrogen dioxide, it has 1.17 times 10 to the 23 molecules of nitrogen dioxide. Next, we have our mass percent. So basically, the formula is just this. We calculate for the mass percent of an element using the mass of a particular element in a compound divided by the molar mass of the compound. So as an example, we have the effectiveness of fertilizer depends on their nitrogen content. Ammonium nitrate is a common fertilizer. What is the mass percent of each element in ammonium nitrate? And determine the mass in grams of nitrogen in 650 grams of ammonium nitrate. Ammonium nitrate is NH4 NO3. And it has a molar mass. It has a molar mass of 80.06 grams per mole. Then we make use of how many of an element is present in a compound. For example, we make use of the subscripts. We have 4 hydrogen atoms, 2 nitrogen atoms, and 3 oxygen atoms. So we make use of those. So 4% nitrogen. So we know that it has 2 moles of nitrogen since it has 2 ka nitrogen. Then we convert them to mass using the molar mass. Okay. we convert them using the molar mass of the particular element. So for this case, we make use of the atomic weight of nitrogen, which is 14. So it is equal to 28. Twenty-eight 0.02 grams of nitrogen. So to compute for the percent of nitrogen, again, for ammonium nitrate, we have 28.02 grams of nitrogen, and we divide it by the molar mass of the whole compound. Then times 100, we get 35% nitrogen. So in the compound ammonium nitrate, it has 35% nitrogen. And for practice, you can calculate for the mass percentage of hydrogen and oxygen. So we know that ammonium nitrate has 35% nitrogen. So to determine the mass nitrogen in 650 grams of ammonium nitrate, we multiply that value, grams, we multiply this value to the percentage of nitrogen, which is 35%. Then we will get 228 grams of nitrogen. So per every 650 grams of ammonium nitrate, it has 228 grams of nitrogen. So another problem, we are asked to convert mole percent to mass percent of an alloy, which is composed of 70.8 moles of palladium and 29.2 moles of nickel. Express the composition of this alloy as weight percentage. So for this problem, we assume 1 mole of alloy. So to determine the mass of palladium, we get for 1 mole of alloy, it has 70.8% Pd. Then we multiply it to the atomic mass of palladium, which is 106.42 grams palladium per mole Pd. Then we get 75.35 grams Pd. So the same thing for nickel, 1 mole 1 mole alloy times the mole percent of nickel. Then we multiply it to the atomic mass. Then we get 17.14 grams nickel. So for the whole alloy, we add them together. Then it has a mass of 92.49 grams alloy. So to convert mole percent to weight percent, we make use of this calculation. Then we will be using the total mass to calculate for the weight percentages of each element. So weight percent of PD is equal to 75%, 75.35 grams PD, and the total mass, 92.49 grams alloy, times 100. And we would get 81.5% palladium. Then the same thing goes for nickel. We just change the numerator to the mass of nickel. Then we will be getting 18.5 weight percent nickel. So next, we are to determine the empirical formula and molecular formula of substances. Empirical formula basically means the simplest chemical formula for a substance. It shows the lowest whole number of moles and thus the relative number of atoms of each element in a compound. And the empirical formula is usually determined using mass analysis. Molecular formula, on the other hand, it is the actual number of atoms of each element in a molecule. Molecular formula is what we commonly see. So these are the steps of determining the empirical formulas of substance. First, we determine the mass of each component element. Then we convert those to mass to amount. In other words, grams to mole. Then we convert the amounts mathematically to whole number integer subscripts. We convert them since walang exists na 1/2 of an element in a substance. So as much as possible, the subscripts are of whole numbers. Then to accomplish this math conversion, we divide each subscript by the smallest subscript. If necessary, multiply through the smallest integer that turns all subscripts into integers. So it is better visualize using an example. Analysis of a sample of an ionic compound yields 2.82 grams of sodium, 4.35 grams of chlorine, and 7.83 grams of oxygen. What is the empirical formula and the name of the compound? So we are given the following values of each element in the ionic compound. So we convert those to moles. So 2.82 grams of sodium times the atomic weight of sodium, which is gram sodium and mole sodium. So we would get 0.123 moles of sodium. Then 4.35 grams of chlorine, we divide it by the atomic weight, 35.45 grams chlorine per 1 mole of chlorine. We get 0.123 moles of chlorine. Same thing goes with oxygen. We divide the mass by the atomic weight. Then we would get 0.489 moles of oxygen. Then we make use of these values as the subscript of the empirical formula. So sodium 0.123, chlorine 0.123, then oxygen 0.40. So since the required subscript of chemical formulas are integers, we make use of the steps. So we should divide them by the smallest subscript calculated. So since the smallest is 0.123, we divide all of the subscripts with 0.123. So then we would get NaClO NaCl 3.98. 3.98 is just approximately equal to 4. So the empirical formula is sodium chlorine NaClO4. And its name is sodium perchlorate. Then for molecular formulas, there is a different set of steps to solve it. So first we assume 100 grams of the compound to express each mass percent directly as a mass in grams. So we convert them to moles. Then we follow the steps previously to determine the empirical formula. Then we divide the molar mass of the compound by the empirical formula mass to find the whole number multiple and the molecular formula. Empirical formula mass is just the molar mass of the empirical formula. So we use an example. During excessive physical activity, lactic acid forms in muscle tissue and is responsible for muscle soreness. Elemental analysis shows that this compound has 40% mass percent carbon, 6.71 mass percent hydrogen, and 53.3 mass percent oxygen. Determine the empirical formula of lactic acid and determine the molecular formula. So first, we assume 100 grams of lactic acid. So 100 grams lactic acid. Then we multiply it to the mass percentages. We have 100 grams La, 40% carbon. So we have 40 grams carbon. Then we use this to convert to moles. So ako na lang diretsyon. Ha? Kaya mo raman Japan ng process. 100 grams. Okay, same naman na itong makuha if you multiply sa percentages. So 40 grams C, we divide it by the atomic weights. We will get 33 moles carbon, Then 6.71 grams hydrogen. We divide it with the atomic weight. We will get 6.64 moles hydrogen. Then the same thing with oxygen. So by calculation, we will get 33 moles oxygen. So the empirical formula is this. So we multiply it with the smallest subscript, which is 3.33. Then we will get CH2O. This is now the empirical formula. So we calculate for the molar mass of this compound, of this formula, we will get 30.03 grams per mole. So we will be using this molecular mass to calculate for the molecular formula. Again, so we are first to determine the whole number multiple that is used to find the molecular formula from the empirical formula. So whole number multiple is equal to the molar mass of lactic acid over the molar mass of the empirical formula. So basically the formula for whole number multiple Usually for problems, we are already given with the molar mass of the substance. So that is always the numerator. Then we divide it by the molar mass of the empirical formula we have determined. So using this, we have 94.08 grams per mole, and we have 0.03. So this is equal to 2.99, which is just approximately 3. Then previously, we have the empirical formula. Then, using this, we determine the molecular formula. So C, 1 times 3, H, 2 times 3, then O, 1 times 3. So we will get 3 carbon elements or atoms, 6 hydrogen elements, and 3 oxygen atoms. So this is now the molecular formula of lactic acid. So to proceed, we are now on balancing chemical equations. So first, we determine how many elements are on each side. So for the reactant side, we have 8 carbon atoms, 18 hydrogen atoms, and 2 oxygen atoms. For the other side, we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. So how do we balance equations? It is basically a trial and error, but it is based on how much we multiply on each side. So since we have 8 carbons on the reactant side, it should have, the product side should also have 8. So 8. 8. Then what would we multiply so that the product side has 18 hydrogen atoms? So we multiply 9. So then there's 18 now. However, since we multiplied 8 and 9 to the product side, the number of oxygen atoms on the product side is now affected also. So 8 times 2, we have 8 times 2, we have 16 oxygen atoms plus 9, which is 16 plus 9 is 25. So we now have 25 oxygen atoms. Now, the reactant side, the oxygen in the reactant side is not equal to the oxygen in the product side. So how do we do this? So we supply 25 over 2, since if we were to calculate the oxygen atoms in the reactant side, we just have 25 over 2 times 2 moles oxygen. So, di ba, mo cancel out na siya. So, sa reactant side na natay 25. oxygen atoms. Pero dili man pwede ang fraction. So atong buhaton kay atong i-multiply ang moles sa mga substances nga naa sa chemical equation sa 2 para ma-cancel out ni siya. So 2, ma-cancel out. So ang final na chemical equation now is 2 moles of octane plus 25 O2 yields 8 times 2, 16 carbon dioxide moles. Then 9 times 2, 18 water moles. So nanatay balanced chemical equation. Then another example would be ang explosion sa nitroglycerin, and it produces carbon dioxide, water, nitrogen, and oxygen. So again, we count the number of how many moles or how many atoms of an element are there in the reactant side and the product side. So basically, trial and error na din siya. Natay 3, 5, 3, 9. Natay 1, 2, 2, and 2, 5. So, man ta so good ani. So mag-try ta na i-multiply ang carbon sa product side by 3. So natay 3. Then i-multiply, i-kuhan din nato ni siya ang oxygen sa carbon dioxide. So we now have 3 times 2, 6, plus 1, 7, plus 2, 9. 9 oxygen atoms. So equal sila. Kanina sa dione. Ang 3 or sa hydrogen sa ata. So na ay 5, na ay 2. So how about i-multiply na to sila with each other para ma-equal to 10 ang both sides. So multiply tag 2 and 2 here. So mausab na sad ang number of atoms. So we now have 6. Baluan na po din nato og 6 para equal. Then atong nitrogen now kay 6 and atong oxygen kay 18. So mausab na sa atong product side na numbers. So kung 6 ni siya, i-multiply na lang nato og 3 para natay 6 nitrogen atoms. So equal na po siya. Sa carbon 6, so 6 times 2, 12. Then 14, kini siya, 14, 16. So kulang Japon. So what if multiply na to by 2 ang everything? Yung basin di ay mag-balance na siya. So, how many? So 4 moles of this compound and 12 carbon dioxide plus 4 water, 6 nitrogen, and so i-check na to siya. So 4 times 3, 12, 4 times 5, 20, 4 times 3, 12, 4 times 9, kailangan na, 36. Then sa product side, i-count na to natin 12 carbon atoms. Then sa hydrogen natin 12. I mean, dili po siya. 4 water molecules, so natin 8. Then, sa oxygen natin 12 times 2, 24 plus 4, 28. Then, naput tayo other one, so 30. Kulangan og 6. So, unsa man itong buhaton para may mong 20. Okay. So, unsa man buhaton na ito para may mong 20. Then, on oxygen, may mong 36. So, daan pa lang na atay 24 oxygen atoms gikan sa carbon dioxide plus kini siya oxygen so 2 natay 26 ka oxygen. So mag-add kuno daw tag 10 oxygen para mag 36 ni siya. So na 36 na siya. I-check na po din nato ang hydrogen. So 10 times 2 natay 20. So na-balance na siya. So ang essence lang jud sa chemical equations is trial and error. And it takes a lot of practice para mata-matahon na lang din mo siya. Again, it takes practice para mabalance ang chemical equations. Now we move on to stoichiometry. Stoichiometry, we use the ratios of the chemical equations, the balanced chemical equations, to convert between two substances. So for example, we have substance A, we can convert it to the mass, using the molar mass of substance A. Then we calculate for the entities of substance A by using the Avogadro's number. So to convert the amount of substance A to the amount of substance B, we make use of the molar ratio from a balanced chemical equation. So, maghatag tag example. So for this problem, in a lifetime, the average American uses more than half a ton of copper in coins, plumbing, and wiring. Copper is obtained from sulfide ores such as chalcocite, copper 1 sulfide by a multi-step process. After initial grinding, the ore is roasted, heated strongly with oxygen gas to form powdered copper oxide and gaseous sulfur dioxide. How many moles of oxygen are required to roast 10 moles of copper 1 sulfide? So, according to the problem, para makakuha ta og copper oxide, i-react nato ang copper to sulfide and oxygen. Kini siya. Then moment siyang ore. Kani siya. Then heated strongly with oxygen. So, ga-react sila to produce kani siya nga products. So, copper oxide and so, ang first na to buhaton kay i-balance na to ang equation. So, we have natay three oxygen atoms sa product side, natay 2. So, para mahimong 3 ang sa reactant side, okay, i-multiply na to ang oxygen. Pila ang number sa oxygen atoms to 3 halves. Kaya makancel naman siyang 2, di ba? Para may mong 3. So since dili pwede again ang fractions, kuha na to siya by 2. Then we would get 2 moles of carbon sulfide plus 3 moles of oxygen produces 2 moles of copper oxide rather, plus 2 moles of sulfur dioxide. So, gamito na din natin na siya. Na naman tayo chemical equation. So, 10 moles of copper sulfide kay pila man ang makonsume ng oxygen gikan ana. So, para ma-determine, gamito nato tong ratio na gikan sa chemical equation. So, ang sound man ni para ma-cancel ni, para mahimong moles of oxygen, we multiply it with the ratio 3 moles of oxygen over 2 moles of copper sulfide para ma-cancel siya. So, mangita lang tag-way para ma-cancel in order for us to get the moles of oxygen. Then multiplying, we have 15 moles of oxygen. So, kada 10 moles sa copper sulfide, kailangan siya o 15 moles of oxygen para makaproduce ani nga products. Then, for this problem, we are already given with the balanced chemical equation. So, as a practice, we solve this. Then, If na may questions, i-PM na lang din ko para ma-check na ko inyong solutions. If na may questions, kung saan pagkuha. Then if nakuha rin ninyo ang correct answer, which is kini na mga values, then you are good. So same ra Japon, we make use of our stoichiometric coefficients and form them into a ratio. So we have another problem. Consider the reaction of 2 grams ammonia with 4 grams oxygen to form nitrogen oxide and water. Determine the limiting and excess reactant. How many grams of nitrogen oxide was formed? How many grams of the excess reactant remain unreacted? So first, again, ang limiting reactant kay mao ang galimit sa reaction. Mao ang galimit sa amount of product produced. Ang excess kay ang sobra, ang nabilin after reaction. So, we calculate for them. First, we should set up the chemical equation. Ammonia plus oxygen plus produces nitrogen oxide and water. So natay 3 hydrogen atoms, natay 2, so we multiply them with 2 and 3 respectively para makuha tag 6. Then, since duha ka nitrogen, so i-multiply po nato ni siya by 2. Then, we have 5 atoms of oxygen. The same thing. I-cancel naman. Multiply nato by 2. Mao na din niya itong balanced chemical equation. Then we make use of that. So, para ma-determine nato ang limiting and excess reactant, i-calculate sa nato kung mag-calculate ta gamit ani nga value or kini nga value, then i-check din nato kung unsa ang pinakadako nga amount ang na-produce nga product. So, ato na siyang solve. So, using 2 grams ammonia, we convert it to moles ammonia using the molar mass of ammonia. Then we make use of the chemical equation para sa katong ratio to convert between 2 substances. So, mani atong gamiton nga product. Pero depende ra po na sa inyo. Akong choice kay nitrogen oxide. Akong reference. So, natay 4 moles ammonia. Then 4 moles NO. Then i-convert din nato ni siya into mass. 30 point. Then we will get 3.52 grams nitrogen oxide. So, mo ni atong ma-produce if atong basis kay 2 grams ammonia. So, if atong basis kay 4 grams oxygen, Mao po nato ang gamiton. So same procedure gyapon siya. We have so calculating, we will get 3.00 grams NO. So ma-notice ninyo na differ ang atong ma-produce na product depending kung unsa atong basis. So unsa ang limiting reactant kay mao ang pinakagamay na amount of product nga ma-produce. So unsa man sa ila ang mas gamay? So kini siya ang gikan sa oxygen kung atong basis. Therefore, since gamay man ni siya, so katong atong na basis kay mao to atong limiting reactant. So limiting reactant is oxygen. Atong excess reactant kay ammonia. Nganuman, oxygen kay mao ang pinakagamay nga product na iyang na-produce. Walang excess kay mao ang pinakadako. So how many grams of nitrogen oxide was formed? So kung mag-ask galit ani, ang basis ani kay always ang limiting reactant. Pila ang na-produce sa limiting reactant? Diba? 3 grams NO. Kato na calculate na to previously. Kini. So atong basis always kung unsay maximum nga ma-produce na to nga product kay ang limiting reactant. So how many grams of excess reactant remain unreacted? So mag-use tag kuan, bali minus lang. Ang unreacted is equal to the initial amount of the excess reactant minus the reacted excess reactant. So sa kunin nato pag-determine ang reacted, we make use of katong na-produce sa limiting reactant. So 3 grams NO so same procedure Japon, we make use of the chemical equation. We have then since atong excess reactant kay ammonia mao atong gina-determine kung bilang na consume. So using that, we consume 1.704 ammonia sa reaction. Mao ni ang reacted. Then atong initial nga ammonia kay 2 grams. So ang unreacted ammonia is equal to 2.0 minus 704, which is equal to 0.96 grams unreacted ammonia. So mao na atong answer. So now we proceed with the theoretical, actual, and percent yields. Ang formula sa percent yield is just the quotient of the actual yield divided by the theoretical yield times 100. Ang theoretical yield kay mao ni siya ang amount of product nga gikan sa molar ratio of the balance equation. So ga-assume ta nga 100% conversion yun ang reactants. Wala na yung mabilin sa reactants. Then sa actual yield, kay mo ni atong na-obtain yun. Meaning, for example, sa experiment, atong na-produce na product, for example, 3 grams ammonia lang. So mo to atong actual yield. And it is always less than the theoretical yield. So, example, silicon carbide is an important ceramic material made by reacting sand with powdered carbon at high temperature. Carbon monoxide is also formed when 100 kilograms of sand is processed. 51.4 kilograms of silicon carbide is recovered. What is the percent yield of silicon carbide from this process? So natin given 100 kilograms sand. Then mo ni atong actual yield. Mo ning na-produce sa pag-process sa sand. So first, we set up the chemical equation. Diretsyo na nako siya. So, ano siya. So, paon na to ang theoretical yield based sa 100 kilograms of sand na initial reactant. I-convert sa nato siya to grams. Then, 2 moles of sand. Then, mag-make use ta sa chemical equation para i-convert na to ang silicon dioxide to silicon carbide. Then 2 kilograms. Then we will get so sa atong theoretical yield based sa atong chemical equation, mao ni siya dapat yun atong ma-produce. So ang percent yield is then 51 0.4 kilograms mo ni atong actual yield over the theoretical yield, 66.73 kilograms. Times 100, we will get 77% atong yield. Then next, we have our concentration. Concentration is just the quantity of solute dissolved in a given quantity of solution or of solvent. A solution is comprised of solute and a solvent, and they form a solution. Then mo na ni atong common concentration units, molarity and molality. So ga-differ lang sila sa formula na itong gina-use. Sa molarity, kay natay moles of solute per liters of solution. Sa molality, we have moles of solute per mass of solvent in kilograms. So we follow these units, liters, moles. So example, a solution is prepared by dissolving 45 grams of sodium chlorate in enough water to produce exactly 750 ml of solution. What is the molarity of this solution? We remember ang formula, moles, solute, liters of solution. So atong solute ani kay sodium chloride. So i-convert sa nato ang grams moles. Then we will get ilaman 0.64 moles. Then we use that. Then dapat in liters ni siya always. Then we will get 0.806 molarity of sodium chlorate. So basically, i-substitute lang siya sa equation. Then another problem, biochemists often study reactions in solutions containing phosphate ion, which is commonly found in cells. How many grams of solute are in 1.75 liters of 0.460 molarity sodium hydrogen phosphate? So, atong i-determine ang mass sa solute na present in this amount of solution. So we break it down. So I convert na to na siyang moles, 2 grams. Which is, mo na siya ang molar mass sa sodium hydrogen phosphate. So ma-cancel na siya, no? Para grams na lang din ang mabilin, multiply na to siya sa 1.75 liters para ma-cancel na po siya. Then we will get 114 grams of sodium hydrogen phosphate. Next, i-convert na to ang molarity sa sulfuric acid to molality. Okay. So first, we assume 1 liter of sulfuric acid solution. So, natay or 1,000 ml. I-multiply na to siya sa density. Ang density kay depend siya sa concentration sa solution. So if we have 1,000 ml of solution, we multiply it to the density. Ang mass di ay atong solution kay 1,840 grams solution. Ang solution usually composed sa solute and water. Kaya ang universal solvent that we know of is water. Then, we calculate for the amount of sulfuric acid in grams in the solution. So 8 moles liter solution. Then, times kinag-assume tag 1 liter of solution. So mag-cancel na siya. Cancel, cancel, cancel. Then, we have 1,765.66 grams of sulfuric acid. Now, ang mass of solution is equal to the mass of solute plus mass of solvent equal to mass of solution. So, muna siya tong mass balance. So, atong mass of solute is this one. Mama na itong solute, sulfuric acid, plus atong ginapangita ang mass sa solvent. Then, muna na itong mass of solution. We remember nga ang molarity kay moles of solute over kilograms solvent. Usa ginapangita nato ni siya. So ang mass solvent equal to 74.38 water. So, since kilogram man akong solvent, i-convert na nato siya daan. So we have 0. kilograms water. Then ang molality kay pila man itong moles? We have 18 moles. Kinag-assume ta og 1 liter of solution. I-divide na to siya sa mass of solvent. Water na lang. So ato makuha ng molality is 242 molar. So grabe kay siya sa concentrated. Then we have our dilution. Dilution is usually used if natay parent solution, then gaim ta nga mag-make og solution na less than sa concentration sa parent solution. So ang number of moles kay equal ra siya sa atong nagikuha sa parent solution ug atong gibutang sa iyang product solution. Then we make use of this formula. Initial, then final. So pwede ra siya mabaylo-baylo kung asa nimo. Then we have a problem. A chemist requires 1.5 molars hydrochloric acid for a series of reactions. The only solution available is 6 molars hydrochloric acid. What volume of 6 molars of hydrochloric acid must be diluted to obtain 5 liters of 1.5 molars hydrochloric acid? So itong formula, initial molarity over initial volume, final. So kini siya usually atong ginapangita. Mo ni siya ang volume na atong kuhaon sa parent solution. So for example, atong parent solution kay 6 molar atong ginapangita. Then atong final dapat kay kini siya 1.5 molars. Kaya atong buhaton man ang required nga buhaton kay dapat natay 5 liters of this concentration. So we multiply it. Then we solve for the initial. We will get 1.25 liters or approximately 1.3 liters. Then we have our titration. Ang titration, ang pulos ra jud niya is i-determine na tong concentration sa unknown substance. Pero dapat ang other nga itong ginapareacte dapat known iyang concentration. Usually, kabaluta sa concentration aning naa sa burette. Mao ni siya ang ginatawag na titrant. Then mao ni siyang unknown concentration. Then gabutang tag indicator which indicates nga complete ng reaction. If nanay changes sa color. So for an example, if 24.75 ml of 0.503 molars of sodium hydroxide solution is used to titrate a 15 ml sample of sulfuric acid, what is the concentration of the acid? So first, we set up the chemical equation. So sodium hydroxide reacts with sulfuric acid to produce, kuan naman ni siya, double displacement reaction. So we have, then usually kung ang base o ang acid ga react, ga-produce the water and salt. Salt man ni siya. So i-balance nato siya. And so magsugod ta, there is a known concentration. So we have I-multiply lang nato siya sa norm. Then using the chemical equation, we have 2 moles, then 1 mole, then naman tay volume sa sample. Dapat atong makuha nga product kay concentration sa acid, concentration sa sulfuric acid. So na naman tay mole, i-divide na lang din nato siya sa volume sa sample, which is 15 liters. Then we will get 0.415 molar. So bali, i-convert lang nato siya. In such a way nga ma-determine nato ang concentration sa unknown solution. So we will be ending here for basics of chemistry. For next meeting, we will have our first quiz on Friday. And I will be also posting a problem set that will help you study. And ang deadline ani, this is on September 14. September 14 ang deadline ha, for the first problem set. But ideally, you should be solving it since mora po yung gamiton pang study, especially sa calculations na part para ma-practice mo, especially sa pag-balance sa chemical equations. For that's it for basics of chemistry. The next meeting, we have our first quiz. And that would be all for this meeting.